So this video, I'm going to talk about doing division. No decimals, nothing. I'm going to remind you guys how to do long division. Hopefully you guys remember that. And then I'm going to show you a shortcut that will let you do short division. So we're going to work on this problem, 31,857 divided by 8. And so we're going to take the 31,857, that's the number being divided, and we're going to put that in the division box. And let's start with doing long division. So I'm going to put 8 here. And so you work from left to right. 8 doesn't go into 3, so you can put an X or a 0 or leave it blank. It's really important to keep your place value together. 8 goes into 31. Let's see, 8 times 3 is 24. 8 times 4 is 32, so we're going to say 3. So 3 times 8 is 24. And then we have to sort of figure out what the remainder is by subtracting. 31 minus 24 is 7, right? Okay, so then we bring down the next value, which is 8. And 8 goes into 72 9 times. 8 goes into 8 times 9 is 72. 8 times 10 is 80, so it's 9. So that's 72, which we subtract and we get 6. Bring down the 5. 8 goes into 65 8 times. 8 times 8 is 64. Subtract, you get 1. Bring down the 7. 8 goes into 17 2 times. And then since we're, let's just finish that off. So, So 2 times 8 is 16. Subtract, there's a remainder of 1. So we say remainder 1. Okay, that's the long division technique. I'm going to show you how to do it sort of a shorter way. And it works really well with single digit numbers, not so well with both multiple digit numbers. So the same idea, we'll put 3, 9, 8, 2 into the division box. We're dividing by 8. Now it's going to start the same way. 8 doesn't go into 3, but an X or a placeholder. Oops, I said a 9. I wanted that to be I wanted it to be the same thing. So 8, 3, 1, 8. Oh, that's really weird. I really messed that up. 8, 3, 1, 8, 5, 7. There we go. So these two things, we're doing the same division problem. This division problem and this division problem. Sorry about that. Okay, so 8 doesn't go into 3. 8 goes into 31 3 times. 3 times 8 is 24. So it seems the same, right? The difference is that we can, in our heads, know that the remainder, 31 divided by 8 equals 3 with a remainder of 7, right? So we don't actually have to write that. We can just put the 7 here. And that sort of tells me that the next thing we're going to do is 8 go into 78. So 8 goes into 78 9 times. We knew that from before. Right, so that's a 9. 9 times 8 is 72. The remainder, if you divide 78 by 8, right, you get 9 times 8 is 72. The remainder is 6. So let's change that to so now that's our remainder. I'm just going to put the 6 right here. And now we're going to divide 8 into 65. So 8 goes into 65, as we know from before, 8 times. 8 times 8 is 64. The remainder is 1. So I'm going to put the 1 over here. 8 goes into 17 2 times. 2 times with a remainder of 1. So you can see we got exactly the same answer, but it's the same number of steps. It's just that you're keeping the remainders in your head and just writing them down here, and there's a lot less writing. I find this a pretty easy way to do the long division. It's nice to do long division when you're trying to figure out whether a decimal repeats. So like if we were to do, showing that 1/3 is a repeating decimal, it would be 1 divided by 3, add some decimal points. And now this technique works out really nicely. We can say, 3, put the decimal point up here. 3 goes into 10 3 times. 3 times 3 is 9, remainder 1. So the next thing's going to be a 1 over here. 3 goes into 10 3 times. 3 times 3 is 9, remainder 1. And you can see the remainder 1 keeps coming back. You keep getting 10. So that this is going to be an infinite number of 3s. If it were a calculator, or if we were doing it for real, we would probably say round to the thousands place would be 0.333. If you want to use repeating decimals, it would be point through repeating, although I pretty much hate repeating decimals. So, but the point that I wanted to show you is just this nice shortcut way to do long division, or you could do the long way. Either way is okay.